Well, hi guys, we are going to do a little factoring today, and on this particular problem and the next that we're going to be working on, we're going to use an area model for factoring. But before we do that, I just want to show you how you can use the area model for multiplying. So there's a lot of different ways to use this model, and we might even use it later for completing the square. So if you have a problem that looks like this, for example, x plus 5 a binomial times x minus 3. Okay, you can actually use an area model, remember, to multiply that x plus 5 times your x minus 3 and get your result of multiplying two binomials. So the x times the x is x squared. Negative 3x is here. Whoop. X times 5, 5x, and 5 times my negative 3 is negative 15. So as you combine like terms, your final answer for your multiplication problem is x squared plus 2x minus 15. So this is just one example of how you can use the area model for multiplying, but then when we're factoring, we're kind of utilizing it in reverse, you could say. So the first thing we are going to start with is identifying your A and your C values. And there are different ways to organize this. I'm going to go ahead and organize this just with this X model or hourglass model. It's called many different things probably. And I'm going to multiply my A times my C value. Okay, so in my AX squared plus BX plus C, I'm going to multiply my A times C value. 1 times 32 is 32. And I'm going to place my B value down here as a reference, positive 12. And so what we're going to try and do for factoring with our area model, and also this is going to be the first step as we're factoring by grouping as well, is to find two numbers that multiply to be 32. I want them to multiply to be 32. So I'm trying to think of what those could be. And I want them to add together to be 12, a positive 12. Okay, and sometimes these can get really crazy and big and sort of challenging. So you do have to do a little bit of guess and check, or know your factors, or play with some numbers sometimes to make this work. So I know that 2 times 16 is 32. But those aren't going to add together to be 12 very easily. I do know that 8 times 4 would work. And so essentially what we're doing here is double checking. 8 times 4 is 32. Yes, 8, that works. And then 8 plus 4 is 12, so that works as well. And then these two values are going to jump into my area model over here as 8x and 4x. I'm going to continue to use my 1x squared, and I'm going to continue to use my 32. Okay. So as we're looking at factors of 4x and 32, 4 is common to both. And as we look at factors of 32 and 8x, 8 is common to both. And that's helpful right here, and you can kind of double check to make sure that that makes sense, because 4 times 8 would be 32. So that looks pretty good. And then we also have common factors of an x between these two values, and if you're rolling up your area model, a value of x here as well. So it looks like what we have then is this answer that is your factored form of the trinomial, which is x plus 4 times x plus 8. Now we're not solving yet, but we're going to be solving, so it's really important that you guys are learning how to factor. And there's a lot going on here with this picture that I have going right now, so we're going to try it one more time. And this time our a value is going to be greater than 1, so it's going to be a little bit different. I'm going to switch up colors here. We're going to move on up, kind of start with a blank slate, and here we go. So a little bit faster. My 3 times my 6 is going to be 18 and 11. So we're looking for two numbers that multiply to be 18, but when I add them together, I get my 11. Okay, and remember the 18 came from multiplying 3 times 6. Okay, so that's how we got our 18 right here. Two numbers that could work. How about 9 and 2? 9 times 2 is 18, and 9 plus 2 is 11, so that looks good. I'm going to drop those values into my area model. I'm going to go ahead and grab my first term. I'm going to go ahead and grab my last term. And I'm going to start looking for common factors. So here it looks like a 2 is common. Between 6 and 9, probably a 3. That's looking pretty good. Between 3x and 9x, because there is a number here in front of the x, you want to be mindful of that. It means there's going to be some kind of number or pairing of numbers here for my x values. And then as I come across this way, it looks like x would work. Let's double check this makes sense. 3x times x is 3x squared, so that checks out. 2 times x is 2x, so that checks out. 3x times 3, 9x right there, and 3 times 2 is 6. So, ta-da! So our factored answer for the original trinomial is x plus 3 times 3x plus 2. And again, this is the first step in what we're going to be moving on to next with quadratics, which is going to be some solving. So that's that's coming next. All right. So keep practicing your factoring. Good luck with that. And get good at it because you'll be using it for a long time. All right. Good job, guys.